Astronomers have recently uncovered a perplexing enigma in our galaxy, a star so isolated that its very existence defies conventional understanding of star formation. This star, named CX-330, drifts alone approximately 30,000 light-years from Earth in a region so devoid of life and activity that it has been likened to an interstellar ice desert. Its presence raises fundamental questions. How could a star form in such an inhospitable environment? Is CX-330 a natural phenomenon, or could its existence hint at the influence of extraterrestrial activity? CX-330 stands out as the loneliest star in the Milky Way. Its surrounding region lacks any nearby stars, and the nearest star-forming regions are far removed from its location. This profound isolation leaves scientists baffled as to how CX-330 could have formed in such a desolate area. Could it have formed where it is now, or might it have been catapulted into its current position by some extraordinary and as yet unexplained event? Some theories even propose that CX-330 might not be a true star at all but rather an anomaly, something that challenges our existing laws of physics. Stars typically form within dense clouds of gas and dust, such as the Orion Nebula or the Pillars of Creation. These regions serve as stellar nurseries where hundreds or thousands of stars are born in clusters, often accompanied by planets, moons, and other celestial objects. Observations of these star-forming regions have greatly advanced our understanding of stellar evolution. Yet, CX-330's existence in an otherwise barren expanse turns these assumptions on their head. CX-330 was discovered in 2016 during a routine examination of the galaxy using the Chandra X-ray Observatory. Unlike telescopes such as Hubble or the James Webb Space Telescope, which observe visible and infrared light, Chandra detects X-rays. This capability allows scientists to uncover phenomena hidden in the darkness of space. When CX-330 was first observed as a bright source of X-ray radiation, its true nature was unclear. Was it a star, a galaxy, or perhaps a black hole? Further investigation with other telescopes confirmed it was indeed a star, one undergoing rapid growth and emitting an unusually high amount of energy. This revelation deepened the mystery. Stars in their infancy rarely exist in isolation. They are typically surrounded by other young stars and dense material. CX-330, however, is a solitary entity in a vast void, defying the established norms of star formation. The unusual brightness and rapid growth of CX-330 suggest that it is in an early phase of its life. This contradicts theories that it might have been hurled into its current location after forming elsewhere. The extreme X-ray radiation it emits further complicates the puzzle. These observations raise the possibility that CX-330 represents a new mode of star formation, one that occurs outside the usual dense gas and dust clouds. If CX-330 formed in situ, it might indicate that stars can arise even in isolated, seemingly empty regions. This would challenge our understanding of the conditions necessary for star formation. Alternatively, CX-330 might have formed from an unexpectedly dense gas cloud, compressed into a star without the aid of typical cosmic dust. This process could mirror the formation of the universe's first stars, which existed before stellar explosions created the dust and heavy elements present in star-forming regions today. If true, CX-330 could serve as a window into the earliest days of the cosmos, helping scientists reconstruct the processes that birthed the universe's first stars. Another theory posits that CX-330 might have migrated to its current position. While older stars are known to move across the galaxy, it was previously believed that young stars lacked the mobility to do so. However, researchers have since demonstrated that even young stars can migrate under certain conditions. For instance, CX-330 could have originated in a typical star-forming region but was later ejected due to gravitational influences or galactic events. Such scenarios are rare but not impossible. Galactic collisions, interactions with massive celestial bodies, or the passage of a black hole could produce forces strong enough to fling a young star into an isolated region. These events, while extraordinary, are part of the dynamic and often violent history of galaxies. In billions of years, when the Milky Way merges with the Andromeda Galaxy, similar processes may scatter stars across vast distances, creating isolated entities like CX-330. CX-330's extreme energy output and rapid growth phase have led some scientists to question whether it is a star at all. Could it be an anomaly, a relic of a long-gone star-forming region where it became the last remaining star? Over billions of years, stars in such a region could have exhausted the available material, leaving CX-330 as a solitary survivor. Another speculative theory involves the potential for extraterrestrial influence. In the 1960s, the concept of a Dyson sphere, a hypothetical megastructure built around a star to harness its energy, was proposed by Nikolai Kardashev. Some researchers suggest that CX-330's unusual radiation could be the result of such an alien construction. In this scenario, the surrounding region might not be empty but could be modified in ways that render its matter undetectable to us. While this idea borders on science fiction, it underscores the profound mystery of CX-330. Could the star be part of a larger, alien-engineered system? Such theories remain speculative but highlight the need for further study to unravel the true nature of this enigmatic star. CX-330's isolation draws comparisons to the vast voids that exist between the filaments of the cosmic web. These voids are enormous, spanning millions or even billions of light-years, and contain very little matter. Despite their emptiness, some galaxies exist within these voids, raising similar questions about their formation. The existence of such voids challenges the standard model of the universe, which predicts a relatively uniform distribution of matter. If the universe's structure was shaped by the Big Bang, the presence of voids remains a puzzle. Some scientists speculate that unknown gravitational forces or exotic processes might be responsible for the creation of voids and the objects within them. CX-330 shares characteristics with the sparse galaxies found in these voids. Both represent instances of celestial objects forming in regions that seem to lack the necessary conditions. These phenomena compel researchers to reconsider our understanding of the forces that shape the cosmos. The discovery of CX-330 has profound implications for astronomy. It challenges long-held assumptions about star formation and raises questions about the processes that allow stars to exist in isolation. Whether CX-330 formed through an unknown mechanism, migrated due to extreme gravitational forces, or represents an entirely new phenomenon, it stands as a testament to the universe's complexity and the limits of our understanding. Further observations and theoretical work are needed to explain CX-330's origin and nature. Whether it ultimately provides insight into early star formation, the dynamics of galactic evolution, or even the possibility of extraterrestrial technology, CX-330 promises to deepen our appreciation of the mysteries of the cosmos. In a galaxy teeming with stars, it is often the loneliest ones that teach us the most. In typical star-forming regions, the interplay of gas and dust is crucial for the birth of stars. These materials collapse under gravity within vast molecular clouds, initiating nuclear fusion at their cores. Regions like the Orion Nebula are bustling with such activity, churning out stars, planets, and other celestial objects in massive quantities. However, CX-330 exists in stark contrast to these stellar nurseries. Its region lacks the dense gas clouds associated with star birth. How then did CX-330 come to be? One theory posits that a previously undiscovered, dense gas pocket could have existed in this desolate area. The star may have formed from this pocket, even in the absence of cosmic dust. Such a process would be unprecedented but not impossible, potentially mimicking the conditions of the early universe. During the cosmos's infancy, the first stars, known as population 3 stars, formed exclusively from hydrogen and helium. Without dust or heavy elements, these ancient stars condensed under intense gravitational forces. If CX-330 represents a similar phenomenon, it could offer a rare glimpse into a primordial mode of star formation, providing insights into the earliest epochs of the universe. Another possibility is that CX-330 was ejected from a traditional star-forming region. Galactic collisions, black hole interactions, or gravitational slingshots could have flung this young star into its current position. While these events are exceedingly rare, they are not unheard of. The Milky Way itself is on a collision course with the Andromeda Galaxy, an event that will trigger widespread disruption across both galaxies. When such cosmic encounters occur, stars can be violently displaced, thrust into isolated regions. Similarly, a massive celestial body passing near a dense star cluster could generate enough gravitational force to eject stars, creating anomalies like CX 330. At Space Lab, we uncover the universe's greatest mysteries. Stay curious, and keep exploring.